Alrighty, we are still in section 3.3. This is our first attempt to use what we know about derivatives to tell us about the extrema of a function. So remember the difference between the kinds of extrema that exist. There are relative extrema and then there are the global extrema. So when we're talking about relative extrema, remember we're talking about a low point or a high point, right, in, a tiny little window around that function, okay? So this particular test that we're doing today is called the first derivative test, which is exactly, it is what it describes. We're using the first derivative to test where we have relative extrema. So that's what this test finds, okay? Remember that relative and local are interchangeable words. Okay, so we've got three functions here, and I just want to remind you about, the task of finding critical numbers and what that does. So critical number here, right, is a place where the derivative equals 0. Critical number here is a place where the derivative equals 0, right? It's got 0 slope. And then in between that, right, we are, let's go decreasing, right? And then after that critical number, we switch to increasing, right? And then we switch from increasing at that critical number, that high point, to decreasing. So when we have this change from red to blue or blue to red, that indicates that we have an extrema, right? So the sign of the derivative, okay, remember back when we did this for increasing and decreasing intervals, this derivative is negative everywhere. It's negative everywhere in here. The slopes, right, are negative. And then in between those, we've got positive slopes everywhere. And when it transitions from one sign to the next, that's the indication that we have an extrema, okay? Right here on the next function, right, this is a cusp, right? So this is a place where f prime does not exist. That counts as a critical number, right? And then if you think about what's going on both sides, we are decreasing on this side. All the slopes are negative. And then we switch and we start increasing on this side. And again, we have that, sense that we're going from red to blue. So that means our function is going from decreasing to increasing, and it must be a local minimum. Okay. The least interesting kind, I guess, is really what I should say, is a point like this right here, where the slope is 0, right? So f prime does equal 0 at this location. Tangent line's horizontal. But if I think about what the graph is doing, right, it's decreasing, right? All those little slopes are negative on that side. And then it hits a slope of 0, and then it keeps decreasing. So sometimes there are situations where we have a critical number, but the sign change because it does not change sign, right? The derivative is negative, 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 negative. It hits 0 for a moment, and then it's negative, 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 negative some more. We actually don't have any extrema there, okay? And you can tell by the picture, right, that point is not a maximum or a minimum. It's what I kind of referred to, I make this up. I'm going to call this a saddle point, which is actually a term to describe something like in Calc 2, which I don't remember what it is, or Calc 3. But again, I kind of think of this, kind of like the back of a horse, and this is where the saddle would ride, right? And then here's the horsey's face, and then, we've got the horse's tail. So anyway, this sort of feature where you have that decreasing and then decreasing some more is not an extrema. Look at this guy. Let's see where we can go. Girl horse, maybe. Anyway, all right, enough of that. Let's go ahead and explicitly state what the first derivative test is. So it's a very simple test. F has a local minimum. Okay, whenever we have the derivative going from minus to plus on a critical number. So this is the sign chart, right? So f prime equals 0 or does not exist at this critical number. Okay, so whenever f, if we say it in words, we say f prime goes from negative to positive. Okay, and vice versa. If we have f having a local maximum, if the derivative changes sign from positive to negative at a critical number, right? So that would mean f prime goes from positive to negative, and that means for sure that we have a max. If it switches in the other order, then we have a min. Okay, so this test is going to rely on our ability to make sign charts and then do the analysis therein. Okay? So let's look at the first example. It says find the relative extrema of f of x equal to x plus 2 squared times x minus 1. Justify your answer. So this is a cubic function, right? If we think about what the power on x would be if we were to multiply everything out. So we're going to start by doing a derivative and getting the critical numbers. So in order to take this derivative, I'm going to use the product rule. When I think about the product rule, this is my first function, and then this is my second function. So I'm going to do the first times the derivative of the second. The derivative of x minus 1 is just 1, plus the second function, which is the yellow guy, times the derivative of the orange function, right, which is 2x plus 2 to the first power. And then if there was a number there, remember I'd have to multiply it. But there's not, so I don't. Okay, now we have to set this bad boy equal to 0. And as I've recommended in the past, the easiest way to get it equal to 0 is to factor. So I see in this term and this term, they have an x plus 2 in common. So I'm going to factor out an x plus 2. And then left inside will be 1 factor of x plus 2 from the first one. And then 2 times x minus 1 here in the second one. And then I'm going to simplify what's up in there. So this other set of parentheses, I guess, this is like 2x minus 2. So that's 3x. That's it. It's just 3x, right? So that looks like a negative. Let me write this better. I don't want that to look like a negative. So that's my derivative. So I've got to set that equal to 0. So I get one critical number here. If I set 3x equal to 0, I get 0 as a critical number there. And then I transfer those two critical numbers, that's not what goes first, to my sign chart. And remember that when I test them in my sign chart, I'm testing them in that, actually let's go back and let's use pink. I'm testing them in this function. So let's test negative 10. It's my fave. When I plug in negative 10 to the first factor, it's negative. And then when I plug it into the second factor, it's also negative. So overall, that would be positive. Let's use negative 1 in here. So when I plug that into x plus 2, it ends up being positive times negative. So that is negative. And then let's use 10. I get positive times positive. So overall, that result in that interval is positive. So remember this problem is asking for relative extrema. So we could use this sign chart to talk about where it's increasing and decreasing, but that's not what we're being asked to do here. So if we want to get the extrema, right, I have to now take these x values and figure out what the y values are. So I have a sign change at negative 2 from plus to minus. Okay, but I don't know what the actual extrema is yet. I basically just know, that the x value of negative 2 is where it's at. So I'm going to go ahead now and plug in negative 2 to the original. Actually, let me change colors so that it feels like a separate step here. So now I'm plugging in negative 2 to the original function. I get negative 2 plus 2 squared times negative 2 minus 1 which is basically 0 squared times I don't care, so that's 0. And then I also have the sign change from minus to plus at 0, so now I'm going to plug in 0. I'm going to have another extrema there. So I've got 0 plus 2 squared times 0 minus 1, which is 4 times negative 1, which equals negative 4. So I know this guy is my maximum, and I know this guy is my minimum value because of the order with which they change signs. So remember up what we said the first order test says. If it's minus to plus, it's a minimum. If it's plus to minus, it's a max. So now we have to justify. Okay, so I guess I'm going to go up here. Actually, let's justify in green. So I'm going to say F has a relative maximum of 0 at x equals negative 2 because F prime goes from positive to negative. Okay, I'm using the word of to describe a y value, and then at describes the x value. F has a has a relative min of negative 4 at x equals 0 because F prime goes minus 2 plus. So you can use those abbreviations with those sign changes there. Okay. Yeah, no, let's just let that simmer. Okay, let's do it again here. We got a new type of function in example 2. I'm going to do the same ideas. I'm going to do sign chart or critical numbers first with a sign chart. So F prime of x, taking the derivative, is 2/3 x squared minus 4. Decrease it by 1. And then I'm going to probably simplify this. Oh, failure. God, times 2x, because that's the derivative of the inside function. Now I'm going to simplify this. My numerator is 4x, and my denominator is 3 times the cube root of x squared minus 4. So now I'm going to set the top equal to 0 to get one set of critical numbers, and then I'm going to set what's being raised to that power equal to 0 in the denominator. X equals 0 here, x is plus or minus 2 here. That's a lot of critical numbers, so let's put them on a sign chart. And F prime, giving us signs. I'm going to use negative 10. Okay. The top is negative, and then I'm dividing that by the bottom, which would be positive. So that's negative. If I plug in negative 1, the top is negative. The bottom is negative, so that overall would be positive. If I plug in positive 1, positive divided by negative, so that's negative. And then 10 back to positive divided by positive. So that's positive there. So now I've got a bunch of sign changes, right? It goes from minus to plus to minus to plus. So it looks like I have a local minimum here, a local maximum here, and a local minimum again here because of the minus to plus. Now what I have to do is go ahead and plug all of those into the original function. So I'm going to do that work in the blue from up above. I'm going to figure out f of negative 2. I'm going to figure out f of 0, and I'm going to figure out f of positive 2. So f of negative 2 actually is the number 0. I kind of know that positive 2 is also going to be 0 because when I square that 2, subtract 4, right, I get 0. F of 0 is basically negative 4 to the 2/3 power, which you can leave it that way. I guess you could also call that the cube root of 16. It doesn't work out to be a nice number. It just literally is the cube root of 16. So we know at these two locations here and here, these are my minimums because my sign chart goes minus to plus. and that this guy must be my maximum. Okay, that's kind of not enough. I have to go ahead and justify this work now, right? So since these two are the same y value, I can say f has relative minima of 0 at x equals plus or minus 2. I can group them together because f prime goes from minus to plus. And then the other one I can say f has a relative maximum of cube root of 16 at x equals 0 because f prime goes from plus to minus. Okay. And then just for interest's sake, this function kind of looks like this. Like if you put it on a grid, it comes down, it has cusps, it's got this little chunk in the middle, and then it goes like that. So it's a really obscure function that has a corner here and a corner here of those minimum values that we calculated, and then this maximum is cube root of 16. So it's kind of an interesting function because mainly because of the power of 2 on the x that you then raise to the 2/3 power. So it's the combination of those two things that makes it awkward and something that we don't study very often. Okay, last one, last couple here. Number 3 is same idea. We are going to do a little quotient rule here. So we're going to do low. D high is 1 minus high D low is 1 all over the denominator squared. This one should go a little bit quicker. This simplifies to 1 over x plus 1 squared. So if I can set x plus 1 equal to 0, I've got a critical number of -1. If I throw that down on a sign chart and I test, right, in this function, well, that's not helpful. If I test in that function, right, the bottom is always positive because whatever I get plus 1, square it, it's positive, right? So this function goes like this, and that means that there is no relative extrema. No relative extrema because there is no sign change. Because G prime does not change signs. Okay? And last but not least, I'm going to try to sneak this one in here. This is a little bit of a stretch, but we're going to do this from the graphical side of things. And what we're looking at here is a picture of f prime. And we tackled this a little bit before when we kind of made a sign chart on a calculator, right? And we did this like last week, and we looked at where the function was positive or negative. So same idea, right? Where is my critical numbers? It's weird to say equals does not exist, right? Well, f prime is equal to 0 here, here, and here, right? So my critical numbers are -3, -1, and 2. Remember, I'm looking at the derivative, right? So it's just the places where it crosses the x-axis. Okay, now if I'm to make a sign chart, -3, -1, and 2, wherever it's above the x-axis is positive, and whenever it's below the x-axis, it's negative. So remember, it's, let's go with orange, it's above the, oh, not that, it's above the x-axis in this interval and this interval, and then it is below the x-axis here and here. So that means, right, that if I put signs in my chart that match the sign of the derivative, it's going to look like this. And I've got plus to minus. Here I have a maximum. I've got minus to plus. So here I have a minimum. And then I've got plus to minus. So here I have another maximum. Because remember, this sign chart is talking about the signs of f prime, and it yields the same thing. So the way this question is worded, it says find the values of x where f has relative extrema. Notice it doesn't say find the relative extrema because we don't really know what f looks like. We just know what its derivative looks like. So to answer this question, I would say the values of x, right, are -3, -1, and 2 because f prime changes sign at each value of